Welcome to my science class. In this class, will study chapter Light Basics, class 10 NCERT textbook. In the previous class, we had seen what are spherical mirrors. Here in this class, we will see what are spherical lenses. Let us see what is the lens. A transparent material bound by two surfaces of which one or both surfaces are transparent is called a lens. A transparent material bound by two surfaces of which one or both surfaces are spherical is called a lens. Is called a lens. There are two types of lenses, convex and concave. First, we'll see what is a convex lens. Convex lens. In this lens, both the spherical surfaces, spherical surfaces are bulging outward. A convex lens is also called as a convex lens is also called as a converging lens. Converging lens. Because it converges the light rays. Now we'll see what is the convex lens appears like this. Both the spherical surfaces are bulging outward. This is the principal axis. O is the optic center. O is the optic center. This is the principal focus F1. This is the center of curvature 2F1 on this side. Here also we have got one focus F2, 2F2. So this is called as a converging lens because it converges the light rays. See the rays that are parallel to the principal axis after refraction, they pass through the principal focus. Next one is concave lens. Concave lens. In this lens, the spherical surfaces are curved inwards. In this lens, the spherical surfaces are curved inwards. Concave lens is also called concave lens is also called a diverging lens. A diverging lens because it diverges the light rays. The light rays. So concave lens looks like this. This is the opposing point. This is the principal axis, and this point is called as the optic center O. Here we have got F1 to F1, F2 to F2. In this, the spherical surfaces are curved inward. It's called as a diverging lens because it diverges the light rays. So the rays that are parallel to the principal axis they diverge away as though they are coming from F1. the rays get diverged. Next we'll see the behavior of light rays in lenses. First one, the ray which is parallel to the principal axis. Now we will see the ray that is parallel to the principal axis. How does that behave after refraction? In the case of a convex lens, F1, 2F1, F2, 2F2. So the light ray that is parallel to the principal axis, after refraction, it goes through F2. The ray that is parallel, after refraction, it goes through F2. Now coming to concave lens. F2 to F2. So in the case of a concave lens, the ray that is parallel to the principal axis, after refraction, it diverges as though it is coming from F1. The ray will diverge here. Here the ray will converge. Next ray, the ray passing through the principal focus. Let us see how this ray will behave. In the case of a convex lens, so the ray that passes through the principal focus, after refraction, it Remember, just parallel to the principal axis. Now, when coming to the concave lens, so now in this case, the ray that is directed towards the principal focus after refraction, it emerges parallel. Now we will see the sign convention for spherical mirrors and lenses. The sign convention is a set of rules that you need to follow. These rules will help you to solve the problems. The first rule is that the pole of the mirror should be considered as the origin, and the principal axis should be taken as the x-axis. Pole should be taken as the origin, and the principal axis should be taken as the x-axis. Now, always the object has to be placed on the left side of the mirror or the lens. The first rule is that object has to be placed on the left side of the mirror or lens. Next, all the distances that are parallel to the principal axis have to be measured from the pole of the mirror or the optic center of the lens. All the distances that are parallel to the principal axis have to be measured from the pole of the mirror or optic center of the lens. The distance that you measure towards the left side will carry a minus sign. The distance that you measure from the pole towards the right side, it will carry a plus sign. From the optic center, if you measure towards the left side, the distance will carry a minus sign. From the optic center, what you measure to the right side, the distance will carry a plus sign. Next, the distance that you measure perpendicular upwards will carry a plus sign. The distance that you measure perpendicular upwards will carry a plus sign. The distance that you measure perpendicular downwards will carry a minus sign. You measure downwards, it will carry a minus sign. So I will repeat it once again. The pole of the mirror or the optic center of the lens should be taken as the origin, and the principal axis should be taken as the x-axis, and always the object has to be placed on the left side of the mirror or the lens. Next, all the distances that are parallel to the principal axis have to be measured from the pole of the mirror or the optic center of the lens. The distance that you measure towards the left side will carry a minus sign. The distance that you measure towards the right side will carry a plus sign. The distance that you measure upwards will carry a plus sign. If you measure downwards, it will carry a minus sign. They are the sign conventions that you need to remember while solving the sums. In the please like, share, and subscribe. Thank you.